So in this lesson, what we're going to do is we're going to take a look at, is there a common measurement, or is there a pattern that we can find about the exterior angles of a polygon? So remember, in the previous lesson, we talked about the measure of the interior angles of a polygon, and we determined that the interior angles of a polygon, they sum to n minus 2. So interior angles was n minus 2 times 180. So you created your diagonals and found how many triangles it created, and then multiplied that by 180, and that told you the sum of the interior angles of any polygon. So what I would like for you to do is to start the launch activity. You're finding the measurements of angles A, B, C, D, and E. Okay, and I want you to be able to explain how you found each measurement, and then once you have found the measurements of these angles, go ahead and unpause the video, and we will go over the answer. So to find out what angle A is, we would need to use the conjecture about linear pairs. So we know angle A and this 60-degree angle are a linear pair. So a linear pair sum to 180 degrees. They are supplementary. So 180 minus 60 is 120 degrees. If we look at angle D and angle E, we see that they both create linear pairs with right angles. So since the linear pair with E and D are both right angles of 90 degrees, in order for them to be supplementary, D and E would both need to be 90 degrees. So we have E is equal to 90 degrees and D is equal to 90 degrees. The remaining two angles, B and C, are related to each other. They are both linear pairs, so we are not able to figure out right away what the two measures are. So the first thing that we would need to do is we would need to know how many degrees are in this entire in this case, four-sided shape, a quadrilateral. And from the previous lesson, the quadrilateral sum conjecture said that there are 360 degrees in any quadrilateral. And because we know angles, this 60-degree angle, this letter E, and we know this right angle, we are able to take the 360 degrees and we can subtract 60 minus 90 minus 90. And that would tell us that the remaining angle, angle B, inside this polygon, this quadrilateral, would be 120 degrees. So we find out that angle B is 120 degrees. And that leaves us with angle C, which is a linear pair with the angle B, so that tells us angle C is 60 degrees. So we figured out the measure of all 5 of those angles based off of what we know about the interior angles of a polygon. So what we're going to do today is we're going to figure out two relationships today. We're going to figure out the exterior angle conjecture, and then we're also going to use that to help us figure out what we know about the interior angles of an equiangular polygon, meaning in a polygon whose interior angles are all congruent. So let's start with, is there an exterior angle sum conjecture? Okay, so is there, like we have for the interior angle sum conjecture, is there an exterior angle conjecture? So take a look at this triangle that I gave you. We have a triangle where we have 60 degrees, 60 degrees, and 60 degrees. And if you look at the exterior angles, remember the exterior angles are the angle that is created by a line from the side. So this would be our exterior angle. That would be 120 degrees because it's a linear pair. This would be 120 degrees because it's a linear pair. And this would be 120 degrees because it's a linear pair. So if you look at that, you have that sum, so you have, it looks to be all 3 of these angles are 120 degrees. Now, let's go to triangle number 2. Triangle number 2, we're going to do the same thing. We have an angle that is an interior angle that is 111 degrees. The exterior angle that is associated with that is 180 minus 111 because they are a linear pair. So that's 69 degrees. we have an angle that's 41 degrees, so that angle measurement would be 180 minus 41. That would tell us that this exterior angle would be 139 degrees. And then if we have this last angle, which is 28 degrees, we would have 180 minus 28, which would be 152. Now, I want you to take a second, and I want you to see if you can determine the measurements of the 3 exterior angles and find their sum in the first problem and the second problem. And I want you to see if you notice anything. So pause the video, find their sums, explain what you notice. So if you took a look at that, you would see that you have 120 plus 120 plus 120. That would add up to 360 degrees. If you look at this next triangle in step 2, we have 69 plus 139 plus 152. If you add those together, you get 360 degrees. So, in both of these cases, what did we notice? We noticed that the sum of the exterior angles for both triangles was 360 degrees. Okay, it's a 6. Now, is that true for other polygons? So let's take a look at this quadrilateral, and then we're going to take a look at this hexagon. So if we take a look at this quadrilateral, we have an angle that's 122 degrees. So again, we're going to find the measures of their linear pairs for each of these interior angles. 180 minus 122 gives us 58 degrees. 180 minus 88 is going to give us 92 degrees. We have 180 minus 80, which is 100 degrees. And then we have 180 minus 70, which is 110 degrees. So let's take our exterior angles and let's add them together. 58 plus 92 plus 100 plus 110. 58 plus 92 plus 100 plus 110 is equal to 360 degrees. Interesting. Let's take a look at this hexagon. So if you take a look at this hexagon here, again, we're going to find the measures of the linear pairs that match up with each interior angle. 180 minus 122 is 58 degrees. 180 minus 102 is going to be 78 degrees. 180 minus 149 is going to be 31 degrees. And then 108 minus 103 is going to be 77 degrees. 180 minus 116 is going to be 64 degrees. And then 180 minus 129 is going to be 51 degrees. So again, we want to know what the sum of these exterior angles are. So we have 58 plus 78 plus 31 plus 77 plus 64 plus 51. And if we add all those together, we get, any guesses? 360 degrees. I actually got 359. I think we might have a small mistake somewhere, but it would be 360 degrees. Okay, let's see if I see the mistake anywhere. Let me check something real quick. 1, 2, 3, 4, 5, 6. So we know that the sums are of that should add up to so 122 plus 102 plus 149 plus 129 plus 103 plus 116. I believe what happened here is, since I created this in Desmos, one of these angle measurements is off because Desmos likes to round up. So I'm not sure which angle that would be. We'll call this, we'll change this to 102, which would change this to 78. So change this to 78 here, and that would give us 360 degrees. Okay, again, That is the problem with technology. It likes to do things on its own without checking with me. So again, what do you notice here? Okay, you notice that with a quadrilateral, with a hexagon, with two different triangles, that the sum of the exterior angles all came out to be 360 degrees. So based on those observations, we should be able to make a conjecture about the sum of exterior angles of any polygon. For any polygon, the sum of the measures of a set of exterior angles is 360 degrees. Now, remember, this conjecture is based off of observation, and in order for us to be able to accept this as true, we do need to prove this conjecture, because we know, is it true for every observation that we did not do? So what we're going to do is we're going to do two proofs. We're going to prove first that it's true for all quadrilaterals, and we're going to then do the same thing for a pentagon. So what we know is we're going to use two things that we do know are true. We're going to use the polygon sum conjecture and the linear pair conjecture. We know both of those are true. Those are things that we have either proven or accepted as true from previous lessons. So first off, what we're going to do is we're going to take the polygon sum conjecture and we're going to state what we know about the interior angles of a polygon. This is a quadrilateral, so we know that the interior sum of this quadrilateral is going to be 360 degrees. So we know that S plus P plus Q plus R is equal to 180 degrees. Now, what we want to show is we want to show that A, B, and C, and D, when you add those together, you get 180 degrees. Or my fault, I wrote that wrong. We know that S plus P plus Q plus R is 360 degrees. So again, what we want to show is that the sum of A plus B plus C plus D is 180 degrees. Or my fault, is also 360 degrees. So what we're going to do is we need to rewrite this so that we can get A plus B plus C plus D over there. And so what we're going to do is we're going to use the linear pair conjecture. So what we see here is B and S are linear pairs. So since B and S is a linear pair, we know B plus S equals 180, which tells us that S is equal to 180 minus B. And so we're going to do this for each angle. So we're going to replace S with 180 minus B. We're going to replace P with 180 minus A. We have plus Q, but we're going to replace Q with 180 minus D. And then we have finally R, we're going to replace that with 180 minus C. And we know that that's still equal to 360 because all we did was we replaced S, P, Q, and R with equivalent expressions. So if we look at this, we have 180, 1, 2, 3, 4 times. So 180 times 4, we have 720 minus B minus A minus D minus C equals 360. If we subtract 720 from both sides, we would have, and I'm going to rearrange these variables, we'd have minus A minus B minus C minus D equals negative 360 degrees. Then we don't want minus A minus B minus C and minus D. We want those to be positive, so we're going to multiply both sides by negative 1. And that gives us A plus B plus C plus D equals 360 degrees. Okay? Now, you would do something similar for the proving it for any hexagon that we have. Now, or by default pentagon that you have. All right. Now, here's the deal. I'm not going to go over this proof. Okay? I want you to try this proof on your own. You're going to start off by doing the same exact thing. You're going to state what the interior angles are equal to. Okay, that's all we can say. So step 1, interior angles equal what sum? Okay. Step 2, replace interior angles with equivalent expressions using linear pairs. Okay, finally, step 3, simplify. Now, you're going to do this on your own, and I'm going to tell you right now, this is a very good opportunity to be prepared for either a bonus question on a quiz or on a test. Okay, again, being able to prove the exterior angle sum conjecture for a polygon is a good question for a bonus question on a test or a quiz. Now, moving on. The next question that we want to take a look at is, what is the measure of an equiangular polygon interior angles? Okay, so again, what does that mean? We want to know how do we figure out the sum, or how do we figure out the measure of an equiangular polygon's interior angle? So first off, remember, equiangular means all angles are congruent. So first off, let's use what we know. I want you to write down what we know about the sum of the interior angles of a polygon. So the sum of the interior angles of a polygon is equal to 180 times n minus 2. That is the sum of the interior angles of a polygon. Now, we want to write a formula for the measure of each interior angle in an equiangular polygon. So if we want to know what the measure of each angle is, we would take the sum, and then since all the angles are congruent in an equiangular polygon, we would divide that by n, the number of angles there are. So again, if you want to figure out how big each angle is in an equiangular polygon, you would need to use this equation. Okay, so that is the measure of each angle in an equiangular polygon. Now, what we would like to do is figure out, is there a quick way to figure out the measure of each exterior angle? So if we think about this, we know that the exterior angles is going to be equal to, so if we know that the exterior sum conjecture states that the sum of all the exterior angles is equal to 360 degrees. Now, if we want to know the measure of each exterior angle in an equiangular polygon, again, if all the interior angles are congruent. If all the interior angles are congruent, that would mean now the exterior angles are congruent. So you would take 360 and divide that by n. And this would be the measure of each exterior angle in an equiangular polygon. Now, what we would like to do is take our results from step 2, and we would like to write the formula for an interior angle of an equiangular polygon a different way. How else could we write that? Okay, how do you find the measure of an interior angle if you know the measure? So again, what we want to know is, how do we find the measure of an interior angle if you know the measure of its exterior angle? So another way that we could write this is, we know that each interior angle and the corresponding exterior angle are linear pairs. So if we know that, in this case, let's look at this. If we know that this interior angle and this exterior angle are a linear pair, then we know that that we could find that from 180 minus the measure of each exterior angle, so which would be 360 divided by n. So there are two ways that you could find the measure of each interior angle in an equiangular polygon. So our conjecture for equiangular polygons states that you can find the measure of each interior angle in one of two ways. If you know the sum of the interior angles, then you can take 180 times n minus 2 and divide that by n. So this would be used if you know sum of interior angles. You could also take this and do 180 minus 360 divided by n. And that would be used when you know the measure of your exterior angles. So let's take a look at a few examples. Again, I didn't have these on my paper. You will have them on yours when you're doing these homework. So in each of these examples, we would like to figure out the measure of the missing angles. So let's look at this first problem. We have x, y, and z. So let's take a look at this. We know that we have an equiangular triangle over here. It's an equilateral triangle, which means it's an equiangular triangle, which means that all the angles are the same. So since we know that the sum of the interior angles of a triangle is 180 degrees, we know that all three are the same. That tells us that each of those angles is equal to 60 degrees. So now if those are 60 degrees, we now know that x and y are a linear pair with those two angles that are 60 degrees, which tells us x and y would be 120 degrees. We know that this is a 90-degree angle over here, and if we want to figure out what z is, we have to use the fact that this is a quadrilateral, which tells us there's 360 degrees total in that. So we have 360 minus 120 minus 120 minus the 90 degrees from the right angle. Oops, I typed in something wrong on my calculator. And that tells us that angle z is equal to 30 degrees. Again, that was 360. We had 360 minus 120 minus 120 minus 90. Now, let's take a look at this last one. I want to find out what angle M is. We know that these are all exterior angles that are shown to us. So if those are all exterior angles, we know that the sum of the exterior angles equals 360 degrees at all times for any polygon. So if you take that, we have 360 minus 72 minus 87 minus 49 minus 67. So if you do all that quick mental math or use a calculator like I am, you get that final angle is equal to 85 degrees. So M is equal to 85 degrees. Okay. So while you're working on your homework, if you have any questions, message me on Remind or email me, and then we'll go over any homework questions in class as well.